All right, today we're going to look at just a quick review of area and basic volume and how to use your calculator for certain problems. Tomorrow we're going to jump into 3D shapes where you'll be finding the volume of cylinders and cones and compound shapes, which are made of a couple different shapes. So if you remember back when you learned about area, it is the number of square units needed to fill the inside of a shape. So if you're dealing with a rectangle, it's two-dimensional, it's got a length and a width, you will multiply the length times the width. If you're dealing with a parallelogram, you usually call the dimensions of a parallelogram a base and a height, so that's why your formula is b times h. For a triangle, you have to take half the size of the base times the height. And for a trapezoid, you will be taking half the height, and then you'll be multiplying that against these two bases. Your bases are your parallel sides in a trapezoid. Besides area, it's important that you remember the basics of a circle. The components of a circle that you need to be familiar with are radius. We use the letter R to represent radius. Radius is a line segment that will connect the center of a circle to any point on the outside. Another segment that you need to know about is called the diameter. We use the letter D to represent diameter. Diameter will connect the center of the circle, and it will go all the way across until it hits both opposite sides of the circle. So an important thing to notice is your diameter is composed of basically just two radiuses back to back. So if you ever are given the diameter and you need the radius, you can just cut it in half. If you're given the radius and you need to know the diameter all the way across, you can just double it. The other two important things that you need to know about a circle is sometimes you will be asked to talk about the area of the circle. The area inside, I think in your paper it might have a blue chain. I just highlighted it in pink highlighter, but the area inside the shape is considered the area of the circle, how much space it covers. And the formula you will use for area of a circle is to take the value of pi times r squared. So you can see why we reviewed exponents earlier. The other component of a circle that you need to know is the distance around the outside of the circle. This is called the circumference of the circle, and that's what we're going to practice calculating today. The circumference is when you take pi times the diameter. So on your calculator, what I'd like you to practice is locating the pi button, which is over here on the left-hand side. When you press pi, the symbol for pi comes up on the screen, and it will utilize a very good value of pi, not just 3.14, the approximation for pi. It will use a much stronger value of pi that has more decimal values to it. For this example, we have a circle with a diameter. See, it goes all the way through the center to both sides. The diameter is 15 centimeters. So to find the circumference, we would take the value of pi times that diameter, so pi times 15. If you calculate pi times 15 on your calculator, you should get the value of 47.1238898. And this is the value for the circumference in centimeters all the way around the outside of the circle. So you'll be practicing some more examples where you will be able to use your calculator, use the value of pi to make sure you're comfortable with them. Now what we're going to do is we're going to look at volume. In the past, you worked with volume of just rectangular prisms. This year, we're going to learn a little bit more about volume, and we're going to look at shapes called cylinders and cones and spheres. We're also going to calculate the volume of compound figures, which are made up of more than one 3D figures. So to review, volume is the number of cubic units needed to fill a solid. They're three-dimensional. We're talking about volume, how much space is inside. So what you need to do for any kind of prism is you need to multiply the base area, and we typically use a capital B to represent the area of the base. We will use H to represent the height. So this is what it looks like generally. Volume equals capital B times H. The problem is, in different shapes, the area of the base can be a different shape. But in this example, on this page of notes, we just have a rectangular prism because the base of the prism is a rectangle. It's 5 by 7. The height of this prism is 4. So to calculate the volume, we just need to take length times width times the height, and you'll see it abbreviated LWH. So for that example, we again write our formula. We plug in the components that we found, a length of 5, a width of 7, a height of 4, and we multiply them together. Units are important. We started with centimeters, and when you come up with a three-dimensional volume by multiplying length times width times height, you end up with centimeters cubed. Those are the cubed units that would fill up the entire inside of that prism. Now this prism is a special case called a cube. A cube is when you have a length, a width, and a height that are all the same number. So when you do the volume for this shape, we get 6 times 6 times 6. You learned earlier that you could use an exponent to represent that multiplication that's repeated by using 6 as a base and 3 as your exponents. So how you want to type this in the calculator is up to you. You can type 6 times 6 times 6, or you could use 6 caret 3. Either way, you're going to get 216. And because our units are feet, and it's a three-dimensional volume where we're filling in the space, it's going to be feet cubed. And that's how you'd read your answer. 216 feet cubed, 140 centimeters cubed. So now you're going to take your